Have you ever wondered how the world's oceans are faring in this era of climate change? It's a question that merits our attention, as the oceans are far more than just vast expanses of blue. They are the lifeblood of our planet, a network of intricate, interconnected ecosystems that play a crucial role in maintaining the Earth's balance. They serve as a giant sponge, soaking up about 1/3 of human-caused carbon dioxide emissions and produce more than half of the world's oxygen. But as we pump more and more greenhouse gases into the atmosphere, we're pushing the oceans to their limits. The increased temperatures, the rising sea levels, the acidification, it's a cocktail of climate-induced changes that's putting the oceans and all their inhabitants under immense stress. Now, imagine the oceans not as silent, passive entities, but as a living, breathing organism crying out in pain. Our oceans are in dire straits, and they need our help. Did you know that we've lost half of the world's coral reefs in the last 30 years? Coral reefs, the bustling, vibrant metropolises of the sea, play a pivotal role in marine ecosystems. They act as nurseries for 1/4 of all marine species, all while providing food, protection and spawning grounds. Brimming with biodiversity, these underwater cities are often referred to as the rainforests of the sea. But let's take a moment to talk about something known as coral bleaching. This is not some latest beauty trend for corals, but rather a dire consequence of environmental stress. When corals are stressed due to changes in conditions such as temperature, light or nutrients, they expel the symbiotic algae living in their tissues, causing them to turn completely white. This is coral bleaching. Without the algae, the coral loses its major source of food, making it more susceptible to disease and death. Now you might be wondering, how does climate change fit into all of this? Well, as the Earth's temperature continues to rise due to global warming, so does the temperature of the ocean. And when the ocean gets too warm, corals get stressed, leading to mass bleaching events. In the last 3 decades, we've witnessed an unprecedented rate of coral loss. Just to put things into perspective, the Great Barrier Reef, the world's largest coral reef system, lost more than half of its corals between 1995 and 2017. The Caribbean reefs have fared no better, with an astonishing 80% loss in the past 3 decades. And the clock is ticking. According to the International Union for Conservation of Nature, if the current rate of greenhouse gas emissions continues, 75% of the world's coral reefs will face severe bleaching and death by 2043. Coral reefs are the rainforests of the sea, and they're disappearing at an alarming rate. This is not just a loss for the marine life that calls these reefs home, but also for us humans. From food to tourism to medicines and coastal protection, the death of coral reefs has far-reaching implications. You might not realize it, but sea levels are rising 3 times faster now than they were 25 years ago. This isn't some far-off, distant threat. It's a pressing issue that's happening as we speak, and its consequences are far-reaching and profound. So what's causing this alarming increase in sea levels? In essence, it comes down to 2 main factors: melting ice and thermal expansion. Let's start with the melting ice. Both the Arctic and Antarctic are experiencing rapid ice melt due to increasing global temperatures. This meltwater makes its way into our oceans, effectively raising their overall volume and, subsequently, the sea level. To give you a sense of scale, if all the ice in Greenland's ice sheet were to melt, it could raise global sea levels by about 7 meters. That's equivalent to a 23-foot wall of water. Now, onto thermal expansion. You see, as the ocean absorbs heat from the atmosphere, the water itself warms up and expands. This process is called thermal expansion, and it's responsible for about half of the observed sea level rise over the past century. But why should we care? Well, rising sea levels have the potential to cause catastrophic damage. They can lead to more frequent and severe coastal flooding, erode beaches, and even cause entire islands to disappear. Major cities like New York, London and Shanghai, which are located on coasts, are at grave risk of becoming submerged. Moreover, the displacement of people living in these vulnerable areas could result in one of the largest mass migrations in human history. And let's not forget about the immense strain that this would put on global resources and infrastructure. In essence, rising sea levels aren't just a coastal problem, they're a global crisis. Our actions today will determine the severity of their impact tomorrow. We must face this challenge head-on for the sake of our planet and future generations. Oceans absorb a quarter of the carbon dioxide we produce, but at what cost? Our oceans are a massive sink for carbon dioxide, a greenhouse gas that we humans are pumping into the atmosphere at an unprecedented rate. Now here's the tricky part. When carbon dioxide dissolves in seawater, it forms carbonic acid. This is the beginning of a process known as ocean acidification. Let's take a closer look. Carbonic acid readily splits apart in water, releasing hydrogen ions. These ions then combine with carbonate ions, which are abundant in seawater, to form bicarbonate. The problem is that this reaction reduces the availability of carbonate ions. And why does that matter, you ask? Well, many marine creatures, such as corals, oysters and plankton, rely on carbonate ions to build their shells and skeletons. So with fewer carbonate ions in the water, these creatures struggle to grow and reproduce. This is not some far-off problem, it's happening right now. A quarter of all marine life depends on coral reefs, yet we've already lost about half of these reefs in the last 3 decades. Similarly, the populations of many shellfish species are in rapid decline. Studies show that ocean acidity has increased by around 30% since the Industrial Revolution. That's a faster rate than any time in the last 50 million years. At this pace, scientists predict that by the end of this century, ocean acidity could increase by 150%. This is an alarming figure, considering the devastating impact acidification already has on our oceans. And it's not just the creatures with shells that are affected. Acidification can also harm fish, including species that we rely on for food. Changes in water chemistry can disrupt the sense of smell in fish, making it harder for them to find food or avoid predators. Our oceans are becoming more acidic, and marine life is paying the price. Our actions have set in motion a chain reaction that is altering the very chemistry of our seas, threatening the survival of countless species and potentially destabilizing ecosystems that have thrived for millions of years. Climate change has led to the largest migration of marine species in 2 million years. The effects of climate change on our oceans are profound and far-reaching, impacting not just the water's surface but the intricate web of life beneath. Think of it as a domino effect. Rising temperatures and acidification lead to coral bleaching, which then causes a ripple effect on marine biodiversity. Species distributions are shifting at an unprecedented rate. As waters warm, species are migrating towards cooler poles, leaving traditional habitats in search of more favourable conditions. This is not a leisurely journey, but a desperate flight for survival. The North Atlantic cod, for instance, have moved an astonishing 400 kilometres north in the past 4 decades. But it's not just about changing postal codes. These shifts disrupt established ecosystems. Predators and prey, symbiotic relationships, all thrown into chaos. It's a reshuffling of the marine deck, and not all species can keep up. The loss of biodiversity is another alarming consequence. The variety of life in our oceans, the kaleidoscope of colours, shapes and sizes, is dwindling. The International Union for Conservation of Nature estimates that 1 in 4 shark and ray species is now threatened with extinction due to overfishing and climate change. We're also seeing an increase in dead zones, areas of the ocean so devoid of oxygen that they're inhospitable to most marine life. The number of these zones has doubled every decade since the 1960s, and they now cover an area roughly the size of the European Union. And let's not forget the smallest organisms, the plankton. They might be microscopic, but they're the foundation of the ocean's food chain. Changes in their population and distribution can have catastrophic effects up the chain, affecting everything from fish stocks to the largest whales. The scale of the problem is staggering. We're witnessing a dramatic reconfiguration of marine life, a seismic shift in the world beneath the waves. Marine life is on the move, and not in a good way. The state of our oceans might seem like a daunting problem, but we have the power to make a difference. Each of us can take steps in our daily lives to combat climate change. It begins with a simple act of reducing our carbon emissions. We can do this by choosing to walk, cycle, or take public transport instead of driving. At home, consider energy-efficient appliances and light bulbs. Supporting renewable energy is another powerful action. If possible, switch to a green energy provider or install solar panels. Even small actions like using less water and reducing waste can have a significant impact over time. But our individual actions need to be matched by broader societal change. Advocate for climate policies at your local, national, or even international level. Push for legislation that protects our oceans and reduces greenhouse gases. The oceans need our help. We all need to answer their call.